Hello info person, this is Anton, and today we're going to be discussing some truly bizarre cosmic events that are currently challenging our understanding of how stars seem to die and how black holes behave in general. And though for years astronomers assumed that they had a pretty good handle on things like supernova, the massive explosions of various dying stars, extremely recently, in the last 8 years or so, a completely new type of explosions, or transients, as they're known in astronomy, turned this field basically upside down. And in this case you see one of them in this image. This is known as FBOTs, or fast blue optical transients, because they're basically very fast, very blue, and extremely powerful. And so in this video we're going to discuss some of the more recent discoveries about one of these strange events, and discuss what scientists recently discovered when looking at the event AT 2019 IJN. The event that took us just a little bit closer to solving this mystery, but also the event that turned out to be ridiculously rare. And so let's discuss this in a little bit more detail, but first let's start with the mystery itself, in order to basically understand why this is considered to be kind of strange. And that means that we have to first look at your typical supernova, such as a Type 2 supernova that involves a collapsing star. Now generally it depends on what type of a supernova this is, but normally their overall brightness changes in the way you see right here. And so when a typical star explodes, it first brightens over a few weeks, and then slowly fades away over several months, which in this case is almost always the same. Even their absolute magnitude, or total brightness, is extremely similar to one another. But these FBOTs are fundamentally different, because as the name implies, they're fast. They tend to reach their peak brightness in less than 10 days, or much faster than a typical supernova. And at the same time they're extremely blue, basically suggesting that whatever is happening here is extremely hot. With the most famous, and basically the first such event discovered, now nicknamed the Cow. And that's because of its randomly assigned name SN 2018 COW, which basically spells cow. And here, this was at least 10 times brighter than a normal supernova, and was basically the first such event ever seen. But since then, scientists discovered quite a few more, and it's now basically a kind of a tradition to name them after animals. And so here we have the koala, the camel, and the finch. But the two recent studies we're going to be discussing today involve two separate events that were discovered in 2022 and 2019. With the first event, now nicknamed the Tasmanian Devil, mostly because of that TSD at the end, and the second one, AT 2019 IJN, actually being extremely important because it seems to provide us with the smoking gun for potential evidence of what's happening inside. But this event, AT 2019 IJN, does not have an animal nickname just yet. And in this case it's actually kind of challenging to come up with an animal name using IJN, but let's just say it can be like Indian Jackal Nudibranch or something like that. Anyway, obviously it makes no sense, but that's beside the point. Because here, based on these new studies, we might finally have some answers. And let's start with the Tasmanian Devil, the event that was discovered in late 2022. And well, as always, this was pretty far from us, approximately 1 billion light years away, but extremely easily visible because it was so bright. And usually, once an FBOT fades away, it disappears forever. But for some reason, the Tasmanian Devil did something unprecedented. It basically started flaring up again. And so over the course of 120 days, researchers detected 14 separate flashes, or irregular light pulses, with some of them lasting for a few minutes, but actually being just as powerful as the original explosion. In this case equivalent to approximately 100 billion solar luminosities. And well, that's technically a huge deal. Since these flares are so short and so energetic, here the source has to be relatively small. Which basically suggests that the source of this explosion, or the engine driving these flashes, is not just expanding gas like in a typical supernova. And instead this seems to be the result of some kind of a newly formed stellar remnant, such as for example a black hole or a neutron star. And in this case it's doing something actively in order to produce these additional pulses. And so scientists now think it's probably channeling material into these very high-speed jets, which then generate these flashes. But now we have an even more recent paper published in the astrophysical journal Letters. And this is in regards to a transient from 2019. And here this event is a bit of a hybrid, because like an FBOT, it did rise to peak brightness extremely quickly in just 5.26 days, but unlike a typical FBOT, which usually vanishes in a week or even less than that, this one actually decayed extremely slowly and took over 1 month to decrease in brightness. And this is actually a trait that's more common with something referred to as tidal disruption events, TDEs. Basically, when a black hole starts to consume and destroy a star, spaghettifying the star in the process. But for astronomers, the most shocking part of this very strange event was actually its radio emissions. And surprisingly, the radio emissions seems to peak almost 2 years after the optical emissions, or basically 641 days later. And the total luminosity of these radio emissions was 2 orders of magnitude brighter than any known radio bright FBOT or supernova at similar distance. In other words, for some reason this event was producing ridiculous radio emissions that we've never seen before from any such object. With the researchers behind this study concluding that we're most likely seeing an off-axis relativistic jet, or essentially something that resembles this. And so basically here, imagine a black hole swallowing a star. And during this process, a typical black hole is going to shoot out these massive powerful jets going in 2 separate directions. Jets that are usually quite narrow and contain huge amounts of fast-moving plasma that's expanding at nearly the speed of light. But if that beam is not pointed directly at Earth, we don't really see it immediately, but it does eventually come into view as it slows down and expands and eventually sweeps into our line of sight, possibly several years later. And so once it starts to produce these radio waves, that's when we start seeing them, which then resembles a massive delayed brightening in radio waves, because in this case this jet is actively interacting with a lot of gas in the galaxy, with the gas then producing all of these emissions. But there's actually something else really intriguing about both of these events. Not exactly what happened in this case, but where all of this happened. Because for both of these very strange explosions, and also another explosion referred to as CSS 161010, seems to have occurred inside a dwarf galaxy. And that by itself is just a little bit unusual because normally dwarf galaxies are pretty small. And according to the scaling laws of astronomy, when it comes to massive objects, these types of galaxies should actually host what's known as an intermediate mass black hole. A type of a black hole whose mass should be in hundreds and thousands of solar masses, not millions and billions, like what we usually find in galactic centers. And these types of black holes are a missing link in the black hole evolution story, and may potentially represent building blocks for supermassive giants like the one in the center of the Milky Way galaxy, referred to as Sagittarius A star. And so for some of these events, the data suggests that some of the emissions, and specifically the production of jets, possibly involved in intermediate mass black hole shredding a star apart. And so for example for AT 2019 IJN, here the data points at a black hole of approximately 132,000 solar masses, spaghettifying a typical star. But as you can see from this image, it seems to have happened somewhere far from the galaxy and not exactly in the center. In other words, this also implies a wandering intermediate mass black hole that's currently traveling between galaxies. And so what exactly does all of this mean, and what do these events show us? Well, first, this confirms a new class of events we never actually knew existed until relatively recently. And so these are not just weird supernova, instead they actually seem to be a new class of relativistic optical transients that bridge the gap between stellar mass explosions and massive black hole activity. Although in some cases they seem to also involve a kind of an active transition, in this case involving a star actively transforming into either a neutron star or a black hole, and then waking up and interacting with the environment in real time. But because we've only discovered a handful, right now there are still quite a lot of mysteries, and chances are these explanations might change with time. And based on these studies, we now know that it's actually radio observations that will potentially help us discover most of them. And that's because a lot of these jets appear to be off-axis, which means that we're missing quite a few of them every single year. But future radio surveys will potentially be able to discover a lot of these hidden explosions, and most likely present us with new data that will explain everything all at once. And so for astronomers studying these events, this is definitely exciting times. They're continuously discovering new phenomena and new types of explosions we never knew existed until recently. But until we find out more about these events and exactly what happens here, that's pretty much all I wanted to mention. We'll definitely come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying a Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.